We are a team of students from the City University of New York, working on affordable soft exosuits to assist a variety of lower limb impairments that affect more than 200 million people all over the world. Robotic exoskeletons have demonstrated to be a potential solution to provide assistance and rehabilitation together with or in place of conventional physical therapy. However, their wide potential impact is hindered by the stiffness and high cost of commercial exoskeletons. The state-of-the-art devices typically cost more than $50,000 and are primarily developed for people with full paralysis due to neurological impairments.
To address these issues, we have been developing soft and affordable apparel for untethered assistance. As an example, this picture shows an embodiment to aid ankle dorsiflexion. A key contribution of our design is a vacuum-driven origami actuator that connects two braces placed on the wearer's shank and foot. It is made of a 3D printed skeleton wrapped by a nylon fabric and then sealed. When vacuum is applied, it contracts and exerts forces on its two attachment points. The exoskeleton includes a compact motion sensor on the thigh for gait intention detection and a waist belt containing the pump and a control board with electrical and pneumatic components. Here is a video showing the effectiveness of our portable exoskeleton.
At the Center for Wearable Exoskeletons here at TR Memorial Hermann and the University of Texas in Houston, we do a lot of studies using the different lower limb exoskeletons and robots. Many of the robots that we have right now are not practical to be used at home. So we are trying to design a robot that can be put on and taken off easily because it will be lightweight. It will be easy to manipulate. It's something that I predict will be very useful at home for many of our patients. This is not a device that will be produced by roboticists and clinicians that we will suggest to the end users. It's the other way around. The center of this really are the end users.
When I put this on, it actually helped me. I felt that I had more stability, it helped my balance, and my gait kind of went very natural. I felt very comfortable in the sense of, wow, this is going to be my friend.
I love it. It took about, a minute because it's pretty easy. I'm walking a lot lighter. It's very low profile. I don't hear noise when I'm walking. Everyday use, this is perfect.
They have to tell us what they need. They have to tell us what they want so that when we finalize the soft exoskeleton, it is something that will be useful, meaningful, something that will help them in their recovery and their activities of daily living.
Our preliminary results are very promising. The main advantages of the proposed project are that 1, it's cost-effective. The manufacturing cost for a single actuator is less than $5, making the exoskeleton more affordable in comparison to rigid models. 2, it is lightweight. The entire weight of the exoskeleton, including the battery, is less than 2 kg. And lastly, it exerts high forces that are 6 times higher than the conventional soft robots. Furthermore, even though the device is initially conceived for ankle impairment assistance, its fully modular architecture allows this solution to be applicable to knee and hip joints impairments as well. Regarding its appeal to stakeholders, this technology creates value not only for users, but also for insurance and healthcare sectors, thanks to its low-cost nature. Based on the existence of solid prerequisites for concrete commercialization, we are working on advancing the technology to the point where it can enhance independence and the quality of life for people with both neurological and musculoskeletal disorders. To conclude, I would like to share with you some feedback from our collaborator.
Our medical center is the clinical collaborator with Dr. Su's lab. Soft DMG sensor technology is a human-machine interface that monitors the user physiology and varies the power assistance by maximizing the use of the residual or remaining function. Our group plans to conduct the safety and efficacy studies to investigate the usefulness of this technology. This new robot offers a suite of important enabling technologies, from sensors and actuators to AI for a variety of patients with lower limb paralysis. The most promising aspects about this innovation is not only the technology itself, but the translational value, the potential for affordability, and the way that the device will encourage user independence.